Welcome to Calculus. Today we will investigate finding limits of rational functions involving square roots, focusing on an algebraic strategy. Let's take a look at 3 examples. I'm going to head to our notes screen. So you'll see our first limit here is as x equals 4, we want to find the limit for the function the square root of x minus 2 over denominator x minus 4. Let's see why we need an algebraic strategy. Up till now, what we've focused on is direct substitution or graphing. So a good place to start always is direct substitution with limits. So let's just see if that will work here. So I'm just going to take that 4 and I'm going to substitute it in for x. So we're looking at the square root of 4 minus 2 over 4 minus 4. And if we simplify this, for our numerator, we get square root of 4 is 2, 2 less 2 is 0, over 4 less 4 is also 0. And that becomes clear why we need some kind of different strategy. Remember, 0 over 0, we call that an indeterminate form. The 0 in the numerator is okay, but the one in the denominator is undefined. We can't divide by 0. So that's an indeterminate form, if I can spell that correctly. And what that forces us into is some other strategy other than direct substitution to calculate the limit. So we do have graphical strategy, and that's a good one. Sometimes you don't have access to a calculator. So there's things that we can do that will help us calculate the value of the limit that we can do just on kind of pen and paper. So what I'm going to do is I'm going to rewrite this limit. We did a little investigation there with direct substitution. It didn't work. So I'm going to pull this down and let's try something else. So the limit as x approaches 4 of the square root of x minus 2 over x minus 4. So the big problem with this function is the denominator. It's really this division by 0 that's causing me to not be able to calculate the limit. So what I'd like to do is see if I could cancel out that x minus 4. One strategy that we see really starting in Algebra 2 and in pre-calculus is multiplying by the conjugate of a binomial. So just to refresh on what a conjugate is, so take for instance this square root of x minus 2. Its conjugate would have the same terms, square root of x and 2, but instead of minus, it would be plus. And that's how we define a conjugate. It's a binomial that shares the same two terms, but the sign is opposite between the terms. In order for this to be sound algebraically, I need to put that same conjugate in the denominator. And the idea is I can multiply by 1. And really remember, anything divided by itself has a value algebraically of 1. So I'm going to multiply by that conjugate. And again, my goal is to try to cancel out this x minus 4. That's kind of the thorn in the side right there. So let's multiply out and see what that product gives us. So we got a FOIL. So I'm going to put some parentheses around our binomials here. So for my first terms, I'm going to multiply square root of x times square root of x. So I'm going to record here the limit. This is equal to the limit as x approaches 4 of the square root of x times the square root of x. I'll go ahead and write it for this one just so you see all the steps spelled out. So remember, first is the first two terms. The O in FOIL is outer. Those are the bookends. So that's plus 2 times the square root of x. The I in FOIL is the inner terms, and that's negative 2 or minus 2 times the square root of x, and negative 2 times positive 2 would give us the ln FOIL last, so that's minus 4. We'll simplify all that in a moment. Let's deal with the distribution, double distribution down here in the denominator. So I'm going to erase some of these FOIL markings. And let's do the same with this expression. Actually, I'm going to pause. I don't want to FOIL those expressions down below. And the reason, again, is I'm trying to cancel out this x minus 4. So instead of kind of hiding it by doing the FOIL in the denominator, I'm going to preserve it because I want to get rid of it. Well, let's simplify that numerator. So I'm going to bring this equal sign there to the left, so it's still equal to the limit as x approaches 4. And we're just going to start simplifying those terms that we did the distribution. So square root of x times square root of x is going to be x. You can think that's the square root of x squared, and then the square and the square root are inverses. They cancel each other out. So that's just x. Plus 2x and minus 2x, I'm sorry, plus 2 square root of x and minus 2 square root of x cancel each other. And minus 4 is all that's left. And that is very nice because now when I bring my denominator of x minus 4 times the square root of x plus 2, what do you notice? I've got the same binomial in the numerator as in the denominator. Something divided by itself cancels to 1. And that's excellent news for us. At this time, what's left after that multiplication of the conjugate above and below is the limit of, as x approaches 4, of 1 over the square root of x plus 2, and that I can now use direct substitution to find the limit. So I'm just going to substitute in the 4 for x. So notice when I do direct substitution, the limit part disappears because basically I'm saying I'm finding the value of y at that x value. So that's the square root of 4 plus 2. Square root of 4 is 2. So this is equal to 1 over 4. If you want a decimal, 0.25. And that I would box as my answer. So a nice strategy, again, it really all revolves around multiplication by the conjugate. Well, let's take a look at another example here. So I'm going to scroll down to example 2 that has some changes. So notice I do have the limit as x approaches 3 of the square root of x plus 1 minus 2 over x times x minus 3. So we should check to see, does direct substitution work at the outset here? So we're just going to say, okay, I'm going to try it. Let's put in 3 for every x. So this is the square root of 3 plus 1 minus 2 over 3 times 3 minus 3. And you know, you try direct substitution because it's the most direct route. If it doesn't work, then we can try something else, but let's try it. So the square root of 3 plus 1 is square root of 4, which is 2 minus 2 is 0. And then this is down below in the denominator. 3 minus 3 is 0. 3 times 0 is 0. So again, we've reached that kind of downer. It's the indeterminate form. And again, the problem with the indeterminate form is really not the numerator, it's the denominator. So that 0, it's a real thorn in the side because it prevents us from using direct substitution. So we're going to try something else. And whenever you see this structure of a square root of something plus a number or minus a number, that's kind of a key, like, calling card saying, hey, try multiplication by the conjugate. So I hear the call. Let's follow it. So limit as x approaches 3 And as I write this, try to decide what would you write as the conjugate. What are you going to change in terms of the sign? What are you going to keep? So I'm just recording the original here. Over x times x minus 3. So let's multiply by the conjugate. So anything under the radical we want to treat as one term. That does not change. So this is the square root of x plus 1. 2 is unchanged. What will change is the minus. Instead of minus 2, the conjugate will have plus 2. So again, that's just a little insight into what do you do if it's a more complicated radical difference. Well, you just keep the radical part, you keep that other half, change the sign in between them. And just like we did with that first example, the thing that allows us to do that is when we multiply the same conjugate above and below, because algebraically this whole fraction equals 1, and we're permitted to multiply by 1 freely. It's the identity. Okay, so let's multiply this out. So this is the limit as x approaches 3. We're going to FOIL again. So it's first terms, that's the f in FOIL. So square root of x plus 1 times itself, square root of x plus 1. The outer terms are the bookends. So that's plus, I always put the constant out front of the radical. And that just prevents me from thinking that that 2 has gone underneath the square root. Now I'm going to multiply the inner terms, the I in FOIL, so that's minus 2 times square root of x plus 1. And the last terms are negative 2 times positive 2, which is minus 4. Just like we did with the first example, I want to do that foiling thoroughly for the numerator. Really, it's whichever part of the fraction you use to create the conjugate. For the other part, so in this case, the denominator, I want to leave that factored. So with the conjugate there, I'm going to treat it as a separate factor. And I'm not going to FOIL it through. Again, the reasoning there is I'm trying to cancel this piece, and it's needing to be kind of isolated so that when it comes time to cancel, I can do it really quickly. So I'm just going to leave that factored form. Let's combine the things that we see in the numerator. So we need to simplify that numerator. So the limit as x approaches 3. This term, again, usually that first multiplication, square root of x plus 1 times itself, is, so you can think of it as the square root of x plus 1 squared. And just like with the first example, the square and the square root, they're inverse operations, they cancel. So what's left is simply x plus 1. I'll put it in parentheses just so you kind of recognize it. My plus 2 times square root of x plus 1 minus 2 square root of x plus 1 are canceled. And then the minus 4 will just tack on here at the end. Again, for the denominator, I'm just going to transport all those items as factored pieces. Nothing to see here. So I've got one more step to simplify my numerator. So really it's just combining the 1 positive 1 minus 4. So 1 minus 4 is going to give us minus 3. So all of a sudden this becomes limit as x approaches 3. And you can smell success on the wind. X minus 3 above, x minus 3 below. And lo and behold, that cancels out the piece that was making this an indeterminate form. And that's really sweet. You just really never get tired of that cancellation. Well, let's work on what's left. So at this point, we got limit as x approaches 3 of 1 over x times the square root of x plus 1 plus 2. That there is ready for direct substitution. So I'm going to scroll up. We've got a few more lines here because this was a little more complicated. But now I can drop the limit because I'm going to put that value of 3 in anytime I see x. So it's 3 in the denominator times the square root of 3 plus 1 plus 2. So there's no problems now in the denominator. That's not going to be 0. So this is 1 over 3 times, let's simplify what's in parentheses here. So square root of 3 plus 1, that's the square root of 4, which is 2. 2 plus 2 is 4. And that gives us this final answer of 1 over 12. It's a small number. And I'm going to leave that as is. As a decimal, we could figure out what that is, but we'll leave it as a fraction. Fractions are friendly. So same strategy. Even with a more complicated function in the limit, we can still use multiplication by the conjugate to really cancel out the piece that is making that function have an indeterminate form when we do direct substitution. Well, let's take a look at one more variation on this theme. So here I've got the limit as x approaches 1 of x minus 1 over the square root of x plus 3 minus 2. So I think we have the same issue as with the previous two. If we try to do direct substitution, let's try it. You just try it. So I'm going to put 1 minus 1 in the numerator over the square root of 1 plus 3 minus 2 in denominator. So that becomes 0 over square root of 1 plus 3 is the square root of 4, which is 2. 2 minus 2 is 0. And that's an indeterminate form. So it's kind of a downer, but we've got a strategy now. The indeterminate form, it doesn't hold a lot of sway over us when we have this nice strategy. So I'm going to bring the original limit as x approaches 1 of x minus 1 over square root, of x plus 3 minus 2. Now the question here is, should I make the conjugate with the numerator, x minus 1, or should I make it based on the denominator? Good. So the place where we want to go, and this is what makes this one a little different, is you want to go to the part of the fraction that involves the square root. So I'm going to multiply the square root x plus 3 minus 2 by its conjugate, square root of x plus 3 plus 2. So this one's a little different because we're really focusing on the denominator to write the conjugate instead of the numerator. But the bottom line is you go to the part of the fraction that includes the radical. So that is ready then at this point. So this is a little different because what I'm going to keep is the numerator now. So this is equal to the limit as x approaches 1 of x minus 1. So notice I'm not foiling out that numerator. I'm going to keep it in factored forms, times parentheses square root of x plus 3 plus 2. What do you think I'm trying to cancel? Yeah, excellent. I'm trying to cancel x minus 1. That's the thorn in the side right there. So what I'm looking to see is, does the denominator simplify to x minus 1? Well, we've got the foiling. So what we're going to do is multiply first terms, square root of x plus 3 times square root of x plus 3. And then we've got the outer terms. So plus 2. Notice that because of the way that we write the conjugate, it's always the outer and the inner products that cancel out. And it's because we've kept the same values but switched the sign. So it's plus 2 times x plus square root of x plus 3. The inner terms minus 2. So these are like clockwork, canceling the outer and inner products. Square root of x plus 3. The last terms usually kind of persist and cancel with something from the first term. So negative 2 times positive 2 is minus 4. So we'll just go ahead. I'm going to get rid of those distribution lines. Let's cancel what we see. So down below, those outer and inner products cancel. And our next step is going to be equal to the limit as x approaches 1 of this piece we got our eye on to kind of take out, x minus 1 times the square root of x plus 3 plus 2. And then this first product, square root of x plus 3 times itself, is just going to be x plus 3. And then the only other piece is this minus 4. So if I simplify that one more step, that becomes limit as x approaches 1 of x minus 1. So again, notice this one, I didn't do any of the distribution in the numerator. I'm just kind of toting around those two factors forever, it would seem, until now. At this point, we've got x plus 3 minus 4, which becomes x minus 1. And eureka, we've got a cancellation. And that is now ready for direct substitution. Notice this one, everything cancels out and it's no longer rational. It is just a one level kind of square root thing. So this is now equal to the limit as x approaches 1 of simply the square root of x plus 3 plus 2. And that I can now substitute the x value of 1 in for x. So this is, note I drop the limit when I'm doing the direct substitution. So this is square root of 1 plus 3 plus 2. So then we're going to just simplify. The square root of 1 plus 3 is square root of 4, which is 2. 2 plus 2 equals 4. So a nice way of calculating limits of these rational radicals, where initially direct substitution just produces that indeterminate form. We can multiply by the conjugate, and that really does give us a nice entry into solving these. Notice we didn't really graph these at all. So again, what it's giving you is one more strategy, one more tool to calculate a limit based on what's available to you. Thank you for joining for this segment of finding limits of rational radicals. Thanks for joining. I'm going to give you a moment to go work on some of your questions, and I look forward to seeing you in not too long. See you soon.